Hello guys and welcome back, and sorry about the noise. They're cleaning up the lawns, so it's noisy. Anyway, so yeah, let's keep on going. Cool. So we are getting a random here, but I want to find a nearby neighbor, right? So there's a function for that, as you probably already assumed. So I'm gonna say int neighbors, and then square bracket to create a list, because for every primitive there could be more than one neighbors. So this function we're gonna call called poly neighbors will yield an array. So we need to initialize an array based on that yield result. Okay, and 0 for the first geometry, right? And then the primitive, right, which is going to be the picked primitive. So you can say at pick. Okay, now this is going to give us all its neighbors. Okay, just to be able to see what's in there, we can say I at neighbors, I square at neighbors, to create a integer array attribute called neighbors, right? And as you can see, now we're getting 4 neighbors for pick 227. Let's verify that. Toggle on the primitive numbers. We look for primitive 227, which is, where is it? 227, 226, 227 here, right? This guy has 4 neighbors: 226, right? 224, 92, and 110, which is exactly the neighbor we actually have here in the result, which is cool, right? So we're getting the correct neighbors, and we pick a random one in here. Okay, so I'm gonna say int rand pick, and by the way, we don't really need to change that to a attribute. We can just say int neighbors. We just need to visualize it here just to make sure that we're getting the correct results. Now we can say random neighbor pick v equals to a random number again, int rint, basically copying what's happening here on line 3. Fit 01 to a random number. From this time we can say primitive count multiplied up by our current iter number and plus the channel seed. So this time it's going to be a little bit different than that result. Otherwise we're going to get the same result. Okay, so we're fitting 01 there. Okay. Oh, actually, let's see. Fit 01 is this. Let's see. I'm getting a little bit trouble figuring out the parentheses. Just see, that's the random one. So I think this is the one. Okay, we're gonna fit 01 from 0 to 4 now. Okay, we're gonna get 4. Each number is the wrong variable, so let me copy and paste that. Okay, alright, so this is gonna give us a number ranging from 0 to 4, right? And we use that. So we're gonna say int or I at pick neighbor will be equals to neighbors, this neighbors array, right, with this random index. Okay, you can see we're picking, picking neighbor is 0. That doesn't make any sense. Neighbors, so pick well, there's no way it can be 0 unless we're getting a round number here. Oh, right, this is not 0 to 4, this is 0 to 3, because we are looking for a index, right? So it's going to be ranging from 0, 1, 2, 3, right? Not 4. Okay, all by one problem. Alright, so now we have the pick neighbor there. I can drag this. You can see we're always going to get a primitive and one of its neighbors, right? So 190 now, this time, let's see, 190, where is it? 191, 190 is gonna be somewhere here. 182, not in there. Where's 190? It's not in the order that we can find based on that. Let's see. We can do like a blast node to blast out 190 so I can see it. You can type in the number right here. Oh, that's where 190 is. I don't know how I missed that. So 190 is here, and then we're picking 206 as the one we merge, right? Cool. Right. So this is for visualization though. What I really want to do is I'm gonna say int pick will be this one, and int pick nay is that one. Because we're using pick in here, we have to replace that at pick to just pick. Okay. That way we don't really need any attributes. Hopefully. I'm still having the pick somewhere, which shouldn't be. Let's go here and take a look. I'm not sure what's going on in there, but it's not changing with me. I'm trusting that I'm getting just an integer, not an attribute. For those two, I'm gonna give them a group, right? So I'm gonna say add prim or set prim group. Okay, so we're setting the group for the primitive. Okay, and we're setting the primitive group to the first input, right? And then the group name, chosen, the chosen ones, a primitive and its neighbor, right? The chosen ones. And then we're gonna say we're gonna assign that to the pick, the value of 1. Okay, and then that's gonna mean that we're gonna add a primitive group that's 1 for the pick primitive, and of course its pick neighbor. So those two will have 1 for that particular group. Okay, let's run this. If you go to the primitive now, you can see where there's group chosen and only two primitives, 133 and 105 this time, that are chosen, and the other ones not chosen, right? Cool. Let's actually drag it over here, and then all we have to do now is blast out these two and merge them together. So I'm gonna do a blast, and then blast out the chosen ones and delete non-selected. It's gonna give me those two, right? Right, I'm gonna do another node called divide. The divide node can actually do the offset of dividing, which is remove sharp edges. Okay, we can check off the convex polygon, because if you don't check off that, it's gonna add the diameter, the angle actually. So check that off and remove the sharp edges. There is still a point left over, so we're going to do another node called facet to remove the inline points. Okay, that way we're getting this clean face now. Okay, and then you can say this is the chosen one, and then I'm going to go Control C, Control V, others. Okay, and we simply just merge everything back using a merge node to merge everything back now. For these others, of course, it's going to be delete non-selected. Right now you can see we have two faces merged through this one pass, and then we do one more thing called fuse, because even we merge them together, the points are not fused together. Just like how in Maya we combine two models, they doesn't automatically merge any points that are on top of each other. So we have to do one more fuse. As you can see, this is now just 1 point. Before it was like having multiple points in there. So fuse does the trick. Now take a look at the results. Alright, I'll turn off that. You can see now we have a bunch of faces, right, fused together. If we just crank up the iteration to like 100, you can see we have more and more faces getting merged together, which is pretty cool. I change that to like 200 more, right, 1,000. You can see now we're getting pretty cool results, right? A lot of like random pattern. So we can go here and say, okay, I wanted to do something a little bit different. I can go to this core vex snippet, and we can drag the seed. You can see we're getting completely different result when we changed it. Anyway, so this is not over yet. There are two problems. One is that sometimes we pick a random one, but maybe that random one doesn't have a neighbor, so this would yield something wrong, right? This neighbor could be 0 and we're asking something out of it. It's totally wrong in that case. So we need to deal with that. And also we need to know when to stop, right? We can guess a number here, but it would be better if we find a particular stopping point. We can check if there's something to merge. If there's nothing to merge, then we just simply stop the loop, right? So let's implement those things in the next video.